Chapter 2.3 is polynomial and synthetic division. Our goals are to use long division to divide polynomials by other polynomials, use synthetic division to divide polynomials by binomials of the form x minus k, and then use the remainder theorem and the factor theorem. Before we start doing polynomial long division, let's remember how to divide with just numbers. So let's divide, for example, 1,087 over 9. So this is our dividend, and the denominator is our divisor. And we could rewrite it like this, 9 divided by 1087. So the first thing we do is we divide. We see how much can 9 go into 10. So that goes in once. The next step is we multiply. 1 times 9 is 9. The very next step we do is subtract. So notice there are no signs here. We're subtracting. Then 10 minus 9 is 1. Then the next step we do is to bring down the 8. So 9 goes, and then you start all over again. So 9 goes into 18, 2 times. 9 times 2 is 18. You subtract, and then you bring down the 7. And so this 7 here is our remainder. So we can write, this is our quotient, and then our remainder is the 07. So one way we can write our remainder is put it over our divisor, the 9. So we could say the answer is 120 and 7/9. When we're doing long division, our division algorithm is this. So we have f of x. We can write it as d of x times q of x plus r of x. So this is our dividend. D of x is our divisor. Then the q of x is our quotient. And the r of x is our remainder. The big thing I want you to note is that the remainder, we are adding that at the end. Another way to write this is we can say f of x over d of x equals our quotient plus the remainder over the divisor. So this is probably mostly how you've seen it written, but just to kind of go over a couple of things before we start doing long division. Now, just some reminders is number 1, you should write terms in descending order, so in standard form. So descending order of powers. And the other thing you need to remember, really important, is to insert placeholders for missing terms. And you put 0 coefficients. So for example, if we have something that's x cubed minus 2, we would have to put placeholders for our x squared and our x. Okay, so those are just some reminders. Let's go ahead and try dividing using long division. So we're focusing on long division, not quite synthetic division yet. So let's divide this. We have 6x cubed minus 19x squared plus 16x minus 4. So that is our dividend, and that's going to go inside. So am I missing anything? 3, 2, 1, 0. No. I have all my terms. 6x cubed minus 19x squared plus 16x minus 4. And our divisor is this x minus 2. So it's always DMSB, divide, multiply, subtract, and then bring down. Same as long division with just numbers. So what you do is you take a look at this first term. So 6x cubed over x, I'm left with 6x squared. So and that gets written over the same term with the same power, right? So we write it over the 6x squared. Notice that. 19x squared, we wrote the 6x squared above it. The next step is you multiply. So you multiply 6x squared times x minus 2. You could do it in your head, or if you need to, you could always write it on the side. So 6x squared times x minus 2. And then, so this is going to become 6x cubed. So notice it matches. And then minus 12x squared. The next step is we have to subtract. So we change the signs to opposite signs. So the first term cancels, negative 19x squared plus 12x squared. That becomes negative 7x squared. Then we bring down the next term. Then we start all over again. Negative 7x squared over x. So that is negative 7x, and that gets written over the same thing over here, over the 16x. Then we multiply, so negative 7x times x is negative 7x squared, and negative 7x times negative 2 is positive 14x. So notice that you have the same powers, the same degrees next to each other, and so that hopefully should help you out. The next step is, of course, to subtract, so we change the signs, and so this cancels out. Now we're left with 2x and then minus 4. So we divide that last time, 2x and x. So 2x over x is 2. So that is plus 2. Then we multiply. So this is 2x minus 4. We subtract, change the signs, and we're left with 0. So it went in perfectly. So we're going to go ahead and write it. Here's one way to write it, is we're going to say x minus 2 times the quotient of 6x squared minus 7x plus 2. Now it did ask us to use a result to factor the polynomial completely. So this 12, that adds negative 7, so that is factorable. So let's factor it completely. X minus 2, this factors 2, 3x and x. And this is negative 2 and a negative 1. So this is factored completely. So I want you to go ahead and try this example below. Pause the video, and when you come back, I'll have the answer for you. So if you tried this out, when you did long division, you should have gotten 9x squared minus 49. So notice when you subtracted, first of all, it became 0. So you want to bring down the next two terms. So when you bring that down, negative 49 goes in, and then it goes in perfectly. So then you write it as x plus 4 times the quotient 9x squared minus 49. This factors, it's a difference of two squares, and so here it is factored completely. I hope this helps you out. Thanks for watching.